Hello everyone, my name is Juhar Rafid and this is SIT 771 HD Task 7.4. For this task, I decided to make a video presentation on a very important topic, which is abstract classes versus interfaces. Sometimes for the beginner, coder and developer, this becomes a confusing one because they don't know which uh, to use and why it actually matters in different cases. So in this video presentation we are gonna dig a bit deeper on this topic. So let's get started. So let's start with a concrete problem. Imagine you are building a game, a RPG game, and you have three objects on screen: a player, an enemy, and a crate. All three of them need to take damage. The player and the enemy, these two can move around the world, but the crate just sits there. It cannot move. Now, how do you actually model this in code? Take a second to think about it before I show you the obvious answer. Okay, so most people first instinct while solving this problem will think about inheritance. Create a base class, abstract class called damageable entity, and put both methods on it: take damage and move. Then player and enemy both can inherit from it. So far so good. But now we hit the crate. The crate takes damage, so it kind of fits, but it cannot move. And we have just forced the move method onto something that has no business moving. This is the tail. The moment you find yourself writing this class inherits this method but never uses it, you have picked the wrong tool. So there is basically two different questions which the programmer needs to ask. The first question is, what is this thing? A player is an entity. A dog is an animal. That's identity. It's about what something fundamentally is. The second question is, what can this thing do? A player can take damage. A crate can take damage. That's a capability. And it has nothing to do with its identity. Two different relationships. And object oriented programming gives us a different tool for each one. So in this slide we're gonna discuss how abstract class, which is a tool. The tool for is the abstract class. Here's an entity defined as an abstract class. Notice two things. First, it has real implementation. The move method is fully written out with actual code that updates x and y coordinates. Second, it has an abstract method, draw, that's a placeholder. Subclasses are forced to fill that in. Player and enemy both inherit from entity. They both are entities. And critically, they share the move code. They don't have to write it themselves. That's the deal with abstract classes. Shared entity, shared implementation, both at once. Now for interfaces, which is a can-do tool. Here's interface I damageable. It's tiny, just a single method signature. Take damage, no implementation at all. It's a pure contract. Now look who implements it. Player implements I damageable, enemy implements I damageable, and crate also implements I damageable. Crate is not an entity. Notice that. Player and enemy, those two are entity. Crate is not. It does not sit anywhere in our inheritance tree. Its own thing. The interface does not care that it is an entity or not. It only cares whether the class promises to deliver on the contract. No shared identity, just a shared capability. That's the whole idea of interface. So what is the killer difference? This is the practical kicker, the thing that determines in the real world choices. A class can extend exactly one abstract class. You only get one parent, one identity, but a class can implement as many interfaces as you want, as many capabilities as you want. So let's say we are making an interface called iDamageable, iMovable, iCollectible, and all those capabilities can be filled inside the player entity. So most real code bases use both for different jobs. So example 1 is resolved here. So original three objects was player, enemy, and crate. Here player and enemy both extend as an entity and implement iDamageable. They share entity's identity and code. They fulfill the damage contract. Crate, on the other hand, only implements iDamageable. It's not in the entity tree at all. It just promises to handle damage, and that's all it needs to do. Three objects modeled cleanly, each one only carries what it actually needs. So let's prove this is not just a game trick. Let's go to another example. It's a different domain, but it's the same principle. Three things: a bird, a drone, and an airplane. All three things can fly, but are all them the same kind of thing? A bird is an animal. A drone and an airplane are vehicles. They share a capability, flying, not an identity. They are three completely different kinds of things that happened to do the same trick. Here's how it all falls out cleanly. Two abstract classes, animal and vehicle. Different identities, different shared code. Animal have things like eat. Vehicles have things like refuel. Then one interface, iFlyable, the shared capability. Bird is an animal that implements iFlyable. Drone is a vehicle that implements iFlyable. Airplane is also a vehicle that implements iFlyable. The solid arrow shows the identity, what each thing is. The dashed arrow shows the capability, what each thing can do. Two different relationships captured by two different tools with zero awkward forcing. And here's what that actually looks like in code. Animal abstract class has a make sound that subclasses must implement and a shared eat method. Vehicle abstract class has a fuel field and a shared refuel method. iFlyable interface just three signatures: takeoff, land, and an altitude. No code, just the contract. Then bird and drone declare which abstract class they extend and which interface they implement. Notice they are side by side. Same syntax, different meaning. So why this matters? So polymorphism, why this actually matters? This is the payoff. Look at this function, ground all. It takes a list of iFlyable. It does not ask whether each one is a bird or drone or an airplane. It does not care. It just calls land on each of them. One function. Three completely unrelated classes. Different parents, different fields, different code. All handled in a single line. That's polymorphism through interfaces. And it's only possible because we picked the right tool for the relationship. So this is the final decision flowchart, like which tool we should use in real world cases. So when you are sitting in front of a real coding problem, this is the rule you should ask yourself. Do these classes share both identity and a chunk of code? If it is yes, then abstract class. If it is no, then ask, is this a capability that might apply to unrelated types? If yes, then interface. abstract for what it is, interface for what it can do. That's the whole game. This is the quick recap side by side. Abstract class is a models is a relationship, and interface models can do capabilities. Abstract class can hold implementation code, interface only signatures, a pure contract, no field. Interface has no field, no constructors. Abstracts can have fields and constructors. A class can extend one only. A class can implement many. So both are tools for abstraction, and the trick is not picking one over the other. The trick is matching the tool to the relationship. So this is the closing slide where we say the same objects, it's modeled cleanly. Abstract for what it is, interface for what it can do. Thanks for watching.